Greetings and welcome to the Introduction to Physical Science. In this video, we are going to look at the Energy Forms and Changes simulator that is used in some of my classes to demonstrate these as part of some of the lab work that we will do. So let's go ahead and get started. So here is the initial simulator page that we get to, and we press play, of course, to start the simulator. And you'll see that there are two sections. There's an intro and there is a systems. So we will look primarily at systems, but I'll go over intro just very briefly first. And on intro, it has some very basic things here. We have two different items. We have iron, a block of iron, and a brick. We have two different heaters where we can heat things or cool things to various temperatures. And we have two different liquids that we can place things in, and that is water and olive oil. Now, if we want to watch the things, we can turn on the energy, which will show the energy symbols for the different objects. And we can also link the heaters if we want to. And linking the heaters simply means you're bringing them to the exact same temperature. So they can both be very hot or both be very cold. Now, if you don't want to link them, then you can leave them separate. And then that allows you to change one to hot and one to cold as you prefer. So just a little bit of the settings there. Now with these, you can take the brick and you can do things like change its temperature, put it up there. You can heat up the brick and you'll notice that the energy starts to flow. Energy goes from the heat and fills the brick. And then you can take the brick and put it, say, in the water and watch how it heats up the water. And you can watch the temperature. Take the temperature here to really see how the temperature has changed. So if you wanted to see how that changed the temperature, you can then see how that works. Now we can do the same thing with the iron. Let's go ahead and do the iron here, but let's in this case make it cold. So we will start pulling energy out of that as it gets colder and colder. And then we will say, let's look at the olive oil here. Take our iron block here, put it into the olive oil, and watch how the temperature drops a little bit as you do that. Now, as I said, we're not doing a whole lot with the intro in the lab. We're going to mainly work with systems. So let's take a look at systems right now. Now, systems has several different settings that can be used. There are different ways to generate the energy, whether it be a bicycle, a faucet of water, the sunlight, or a tea kettle. So any of those can then be used to generate. Now your generator, there are two options. You have the typical generator here, but you can also use a solar panel. And you have different objects that you can then use to get the results of the energy, which could be things like a beaker of water, or you could replace that with a light bulb, or a compact fluorescent light bulb, or even a fan blade. So we can look at a couple of these examples. So let's go ahead and look at the one that we start with, which is a person riding the bicycle. Let's turn on our energy symbols. Note that there are different types of energy now. You can have mechanical energy, electrical energy, thermal energy, light energy, and chemical energy. So as we start right now, there's nothing. No energy is going on because nothing has started yet. But we notice the energy within the person is all chemical energy within the body. Now we can turn that on and then let the chemical energy change to mechanical energy, which will then go into the generator, and that changes to electrical energy, which then turns the fan, giving mechanical energy again. So we're changing the energy forms. Now, we'll note that in this case, the person runs out of energy, so we have to give more energy to get her going again. And if we watch over toward the left here, we'll see the red coming out here is thermal energy. That is where energy is lost in the system. So because things are not 100% efficient, sometimes energy will get lost. So we're seeing almost all different types of energy except for light energy. Now, let's look at one or two others. We could, for example, turn this into a solar generator, and not all of the combinations work. This is one example that won't do anything. So we can have her pedal as fast as we want to get her fed here, and she can start pedaling and pedaling, and it just turns into thermal energy. So it goes from the chemical energy within the body to mechanical energy in the bicycle to just thermal energy, because the bicycle isn't going to do anything with the solar panel. Let's do something that will affect the solar panel. Let's switch it to sunlight. So now we have sunlight coming out. Now the sunlight will strike the solar panel, convert to electrical energy, which then will move and start our fan moving here. And you can adjust, in this case, the amount of clouds. So right now you have very few clouds, but you could turn that to lots of clouds, which will keep far less getting to the solar panels. And we'll see that over time that fan blades will slow down because very little is getting there and actually hitting the solar panels. And eventually, in this case, that's enough to stop it altogether. Now we can take a quick look at the last two. Solar panel will work only with the sun, but the generator can work with others. You can do it with water. So you can turn the water spout out and let water start going. Again, we have mechanical energy turning the wheel there that is now generating electrical energy and gets the fan spinning, again turning it back into mechanical energy. So we can watch as the energy transforms from one form to another in this. And that continues. Let's make it a little bit faster here. Get the water spinning a little faster, and then that'll speed up the rate at which the fan is blowing. And you will notice every once in a while there will be some energy loss here, and we will get a thermal energy coming out. And there goes one right now. That is thermal energy that occurs because of heat. You heat up the fan. That is some of the energy transfer. Again, we're not 100% efficient. Energy does not go, all the water energy does not convert straight into the energy of motion of the fan. Now, the last one we can look at here is the teapot. So we can stop, we can reset this back to, let's reset it and let's put our teapot on there. Now the teapot isn't going to do a whole lot yet, but we can heat it up. And let's leave our water there and let's see if we can raise the temperature of that water. So we turn it up very hot. That gets the steam going, which will start turning the wheel there. Now as we turn the wheel, we start to generate the electricity, and we'll start to see that here. Oops. Let's turn on our symbols here. And we can see now the thermal energy being converted to mechanical energy, being converted to electrical energy, being converted back to thermal energy as the water heats up. And we can see that water heating, and now the energy is actually starting to leave the water as it steams. So we can see all those different transformations. You won't see every form of energy in each of these. For example, here we see no chemical and no light energy. That's simply because those are not involved in these systems. We're looking simply at thermal, mechanical, and electrical in this case. So again, you can play with the various systems. You can do the same thing with the light bulb there, and we can let the light bulb actually start to burn and glow, where we turn things again back into thermal energy as that leaves. And in this case, we also get, now we get light energy as well. Now we're missing only chemical energy. So we can use this to look at the various ways we can understand how energy, the different forms of energy, and how they change from one type to another. So that concludes this video showing the simulator for energy forms and changes. We'll be back again next time to look at another one of these simulators. So until then, have a great day, everyone, and I will see you in class.